So my name is Fabian Yamaguchi, and I'm going to be talking about ShiftLeft Ocular today, the Google Maps for auditing your code. Let's see, how does this work? There we go. So a few words about myself. I have a background mostly in vulnerability discovery. So I worked as a vulnerability researcher for a company in Germany called Recurity Labs, GmbH, for a few years. And I was more or less tasked on a regular basis with identifying vulnerabilities in software manually. So that included source code audits, binary code audits, or simply black box tests. And what I found back at the time was that the tooling we have to do these kinds of audits is rather limited. And eventually I was a bit frustrated with the situation. And I decided to go back to university and actually do a PhD on developing tools and techniques that we could use to make the life of vulnerability researchers and security auditors easier in practice, with a focus on automating lots of little tasks based on all sorts of pattern-based approaches. So the question was mainly, since what we do is rather repetitive, can we maybe exploit these patterns to get to the bugs faster? And I did that from 2012 to 2015, eventually finished that thesis. And during that time, I developed an open source code analysis platform called Yearn. And you see the logo in the bottom right. And Yearn implemented the idea of taking what's called a code property graph. We'll see what that is in a minute. Putting that into a graph database and then allowing this code representation to be mined for vulnerabilities. Today, I'm the chief scientist at ShiftLeft Inc. And essentially what we're doing here is we're developing different products, but one of the products, and the product that I want to talk about today, is ShiftLeft Ocular. And if you have played with the open source code analysis platform Yearn, then you can think of it as taking Yearn and building it for real, making it production quality software as opposed to a research prototype. Right. So this is Ocular, and Ocular can be downloaded from our website. So if you go to Ocular free trial on Go ShiftLeft.io, you'll find the possibility of downloading the tool that I'll showcase today. Now, Ocular is a tool that's aimed at highly technical users. So this is a tool that's interesting not so much for CISOs, but more for security analysts, people who really work with the code and are really interested in finding the small flaws in the code that allow for it to be exploited. And of course, developers who are interested in securing the software that they're writing themselves, they might find that just as interesting because it essentially allows to find out how code works. And I guess a lot of developer time goes into understanding how code that other people wrote or that you wrote a few weeks ago actually works. The initial Yearn was implemented for C and C++ using a fuzzy parser. At ShiftLeft, we actually recreated everything from scratch. And today we have code querying across different programming languages. And these languages are Java, C#, and C++. Now, if you download the trial version, you will only get the Java language frontend. Just a second. Oh, there we go. You'll only get the Java language frontend, but if you buy the full version, you get the other two as well. And there are some other languages in the works, but yeah, feel free to ask us if your favorite language or your target language is not supported. What you can do with Ocular, and this is what I'm going to demonstrate today, is essentially two things. You can discover how your program is structured, how it interacts with the outside world, how an attacker can interact with it, where the attack surface really is. And the other is you can look for vulnerabilities based on code patterns. And this in combination is pretty powerful and has allowed us to identify a lot of vulnerabilities in a much shorter time frame than you would require if you did not have that tool. And that, I guess, is what I would like to convince you of today. All right. So when you go online and you type in code property graph into a search engine, you'll find a bunch of different presentations on this. And most of them are rather on a theoretical level. And today I want to keep the theory very short because I mostly want to demo what our product looks like. But what you should keep in the back of your mind whenever I say code property graph is what we've done is we've taken lots of different program representations. So things like a package hierarchy or an abstract syntax tree, control flow graphs, dominator trees, all these kinds of representations that are used inside compilers or just inside IDEs to visualize how your code works and to provide different perspectives on your code. We've taken all of these and we've merged them together into one graph structure so that you can ask questions about all these aspects of code, so query all these aspects, and also you can jump from one representation to the other within a query. Now today, so this is kind of like a symbolic picture of what that looks like. We actually, this graph has multiple layers, and today you'll see what's in the Ocular trial version. And in that trial version, you're essentially dealing with the two lowest layers, which is a layer that gives you access to the different instructions, the syntax of the code, control flow, instruction semantics in terms of data flow. And based on that, you can then calculate data flows, you can calculate call graphs and type hierarchies, and we're going to see that in action today. All right. So to make this hands-on, we've chosen one target that we're going to look into today, and that's a program called OpenRefine. So this is a Java program, and OpenRefine at some point was called Google Refine, and it's a tool that journalists use to refine messy data. So you can imagine a journalist gets a public data that is filled with, for example, the contractors that a government has assigned, and in there, well, sometimes something will be called, sometimes you'll have typos in there, and so OpenRefine is a platform used to clean these things up. And so it's a tool that people install on their computers locally, and it brings all sorts of file formats that it needs to parse in order to import data. So an attacker here might be somebody who goes to a journalist and provides this data. And if there are any flaws in the processing of this data, then this can lead to the situation where the journalist's data is exfiltrated.